Hi there! Do you want to know how to obtain the best estimate for the probability that you'll pass your driving test? You'll discover it in this video. Let's start with a warm-up question. Suppose I have two dice, one ordinary die and a loaded one. For the loaded one, the probability of getting 6 is 5 times as much as for the other sides. Now, I choose one die and throw 3 times. This gives first a 4 and then 2 6s. Can you know for certain which die I've thrown? Well, you can't. A throw with either of the dice could lead to 4, 6, 6. So let's rephrase the question. Which die do you think I threw? Intuitively, it may seem more likely that I used the loaded one, since there are 2 6s. But let's do some calculations to find out. If you throw with the ordinary die, the probability of throwing 4 and 2 6s is just 1 over 6 to the power 3. Alternatively, if you throw with a loaded die, this probability becomes 1 over 40. So, with the loaded die, the probability of seeing a 4 and 2 6s is much higher. In other words, it is more probable to throw 4, 6, 6 with a loaded die than with a standard die. And we say it is most likely that the loaded die was thrown. In answering the previous question, you probably chose that parameter, in this case one of the 2 dice, such that the probability of obtaining the actually observed data is the largest. This is the basic idea of the maximum likelihood principle. It is a general principle to estimate parameters, and we can formulate it as follows. Consider the data given. Then, for all possible parameters, compute the probability of observing these data and choose that parameter for which this probability is highest. In class, you will learn a stepwise approach to apply this principle in many different settings. For now, we use the principle to your opening example, your driving tests. Suppose in a year, 1,000 people try to pass their driving test. In the table over here, you see the results. Note that the number of tries that is needed to pass the test is displayed, and some people needed more than 4 tries. You can also see that the distribution among men and women seems different. Let us start by estimating the probability of passing the driving test for women. Denote by capital X the number of tries needed to pass for women. Suppose that every try is independent of the tries before, and that at each try the probability P of passing is the same. Also, this probability is assumed to be the same for all women. We could argue about these assumptions, but for the moment, let's work with them. The stochastic model we obtain with these assumptions is that X has a geometric distribution with unknown parameter P. Now, what would be a good estimate for P? Well, P is just a probability that X equals 1. So, by the law of large numbers, we could estimate P by the number of women that passed directly with their first test divided by the total number of women. For the given data, this equals 0.30. However, we do not use all available data in this estimate, so it is probably not optimal. Nevertheless, it makes sense to use it. Let's try another method. Recall that the expectation of a geometric distribution is 1 over P. So again, the law of large numbers suggests to use 1 over the sample mean as estimate for P. However, you'll have to ignore the last column in order to compute this average. So this method overestimates P, since it leaves out the women who need more than 4 tries to pass. Now, let's apply the maximum likelihood principle. Remember, that means that we want to find the value of P such that the data, here the table with results, is most probable. Denote by xi the number of tries that woman I needs to pass her driving test. Then all xi have a geometric distribution as already mentioned. In particular, the probability a woman needs at least 5 tries is 1 minus P to the power 4. In order to apply the maximum likelihood principle, we will have to compute the probability of observing the data as a function of P, and then maximize for P. This function is called the likelihood. That's why we use capital L to denote it. Let's find this function L of P. The probability of observing the data is the probability of having 150 women pass at once, 125 women in 2 tries, etc., etc. By independence, we get this expression where the constant c is the number of ways we can assign 150 ones, 125 twos, etc. to 500 women. The value of c is irrelevant, as we will soon see. Next, we use the probabilities of the geometric distribution and we get the expression over here. Then we simplify the expression to this, which looks a lot better, right? Okay, once again, remember that we want to find the value of p for which this expression is maximal. Well, we can simply take the derivative with respect to p, set this equal to 0, and solve for p. We find that the derivative is 0 if p is 0, 1, or 3/8. However, the maximum is only attained in this last point. Check this yourself. So using the maximum likelihood principle, we find 38% as estimate for the success probability of a woman passing her driving test. Note that in this case, the maximum likelihood estimate is indeed smaller than the estimate based on the sample mean. You should test your understanding of the maximum likelihood principle by computing the maximum likelihood estimate for men. You can take your answer to class.